Welcome back to my channel, and this will be on the series of binomial theorem. So let's go now how to generate terms in binomial. So we have x plus y raised to power 2, and we have to generate it without using the binomial theorem. We can do that using the using the Pascal triangles coefficient. We can do that without doing the using the combinatory coefficient. We can use the Pascal triangle coefficient. Good. So we have x plus y raised to power 2. And how do we generate terms in binomial? There's a particular order you do that. So we have x raised to power 2. Now how do I do that? You take the highest power, take the number here, raise to the highest power, and the next one, the raise will be what? We decrease, will be what? We start with 0. Are you getting? So the power here and this is start with 2, start with what? Start with 0. That's the first thing you should know. Start with 2, start with 0. And the next thing, the next time, you decrease this by 1, you decrease this by 1, you increase this by 1. Increase that by 1. Are you getting? The next, you have a what? An x raised to power what? 0. So you take 1 from this, increase this by 1. 1 plus 1 is 2, increase by 1. So you have a 2. Now you can say we have reached the what? We have reached the highest value. So we stop there. But what will be the coefficients here, and here? We use the what? We use the Pascal triangle coefficient. What is P2? P2 is what? 1, 2, 1. Can you see that? That means here is what? It's 1, 2, and 1. You can see we've done it what? We've done it without the using the what? The binomial theorem. So this is the method that hinge on what? Pascal triangle coefficient. And this is what? X squared. This is 1. This is 1. 1 multiplied 1 is 1. This you have this. This x raised to power 1 is what? Is x. Y raised to power 1 is y. 1 times 1 is 1, because this is 1. As 1 times 1 is 1. And you have y squared. Good. Next one, you have x plus y raised to power 3. How will I generate this? Very easy. What will I do here? I will just take a what? An x raised to power 3. Can you see that? X raised to power 3. The y start from 0. So you have y raised to power 0. Next one, you have a what? Decrease by 1, increase by 1. Decrease by 1, increase by 1. Can you see that? And last one will be what? So plus, I'll be cleaning this off. Plus x raised to power 0 and y raised to power 3. But what will be the coefficients here, and here? Very simple. I'll use power what? I'll use the Pascal triangle of 1, 3, 3, 1. You can say 1, 3, 3, 1. So I have a 1, I have a 3, I have a 3, and I have a 1. So that means I have a 1. This is 1. This is 1. And this is have a what? You have an x cube. You have a 3 x squared y. But this is y. This is what? 3x y squared. And that is what? Y raised to power 3. So that is how to what? That's how to expand x plus y raised to power 3 using the Pascal triangle coefficient. You can see the triangle gives a faster way of what? Of evaluating Pascal triangle. A binomial of what? Expression of what? Of this. Good. Let's take an example. Let's try for the first power. For the first power, my P4 14641. You can take my other videos on what? On Pascal triangle. So let's take for this. This will be what? X raised to power 4. Start with the highest power. Start with the highest power. X raised to power 4 and y raised to power 0. I'll be cleaning this off. I'll clean this up. I have what? X raised to power 3 and y raised to power 1. I have x raised to power 2 and y raised to power 2. I have x raised to power 1 and y raised to power 3. I have x raised to power 0 and y raised to power 4. Can you see I'm what? I'm increasing and what? And I'm decreasing. I'm decreasing this, I'm increasing this. Good. Now what is the values here? The values here will be what? 1, 4, 6, 4, 1. So it will be 1, 4, 6, 4, and 1. Because I'm using the Pascal triangle coefficient. And that is equal to what? x raised to power 4. This is 1. 1 times 1 is 1. You have x to the power 4. Then you have 4x cubed y. Then you have 6x squared y squared. Then you have 4x y raised to power 3. And here you have what? Y raised to power 4. So that will be the expansion of this without expanding it. You can see this is an easier way of expanding a binomial expansion without using the word, without expanding it in an elaborate way. So let's take out for P5. P5 is 1, 5, 10, 10, 5, and 1. That means I can check out for x plus y raised to power 5. That will be what? That will be x raised to power 5, y raised to power 0. And what do you observe, guys? You can observe that this answer has 5 terms. 1, 2, 3, 4, 5. 5 good different terms. You can see this is how it works. Try to work, it has a different number of terms. Let's go to this. You have x raised to power 4 and y raised to power 1. You have x raised to power 3, y raised to power 2, x raised to power 2, y raised to power 3. And you have x raised to power 1, y raised to power 4, and you have a what? You have x raised to power 0, y raised to power 5. So yeah, to be what? To be 1, to be 5. You have a 5 here, you have a 10 here. You have a 10, you have a 10. You have a 5 here, and you have a 1. You can see this is how it works. What is this? 1. It's 1. You have a what? X raised to power 5. Here you have a 5x raised to power 4. Y. What is y raised to power 1? You have 10x cubed. And y squared. You have 10x squared and y cubed. You have what? 5x. Y raised to power 4. And the final one is what? Y raised to power 5. You can see I can delegate what? Expansion of this without using the word binomial theorem. Just by using what? By knowing my Pascal triangle coefficient. And I would like you guys to subscribe and like my videos and share to your friends. Thank you.